Okay, this is wall systems building construction. So there are different types of walls. We have the load-bearing wall, non-load-bearing wall, cavity walls, shear wall, partition wall, panel wall, veneered wall, and face wall. A load-bearing wall is a wall that is an active structural element of a building. That is, it bears the weight of the element above said wall, resting upon it by conducting its weight to a foundation structure. The material most often used to construct a load-bearing wall in large buildings are concrete, block, or brick. There are different types of load-bearing wall. We have the precast concrete wall, retaining wall, masonry wall, pre-panelized, load-bearing metal studs wall. We have the stone wall and the shear wall. The precast concrete wall or the precast load-bearing walls provide an economical solution when compared to the conventional column, beam, infill wall system. The primary advantage are speed of construction and elimination of wet trades. In adapting the wall thickness, structural adequacy is not the sole consideration. Other factors to be considered include connection details for supported beams and slab, sound transmission and fire rating, joint details of panel-to-panel connection, and possible future embedded services, which could reduce the concrete area available. This is a sample of a drawing of a precast concrete wall system for a building. So as you can see in the drawing, there are a variety of precast systems that are being used to build this structure. We have the precast party wall, they have a precast rear facade wall, they use a precast roof slab, precast stairs, precast front facade wall, and all of these precast system are all structurally load-bearing systems. Another type of load-bearing wall is the retaining wall. Rigid wall used for supporting soil laterally so that it can be retained at different levels on two sides. Retaining walls are structures designed to restrain soil to a slope that it would not naturally keep to a steep or near vertical or vertical slope. They are used to bound soils between two different elevations, often in areas of terrain possessing undesirable slopes or in areas where the landscape need to be shaped severely and engineered for more specific purposes, like hillside farming or roadway or overpasses. A retaining wall that is retained soil on the backside and water on the front side is called a seawall or a barkhead. These are different samples of retaining walls. The one on the left side is a gravity wall. The one in the second to the left side is the piling wall, which is also called the shear wall. Another one is the cantilever wall, which has a foundation that extends towards the embankment. And another one is the anchored wall, in which the sheet piles are anchored to the soil.
Retaining walls serve the important role of holding back soil and rock, just as dams hold back water. The first video in this series showed that granular materials such as soil and rock generate horizontal pressures that increase linearly with depth. Retaining walls must resist these pressures, and many strategies exist for doing so. In this video, we focus on the popular L-shaped cantilever design. If you were going to use an L-shaped wall to hold back soil and rock, as represented by these marbles, would you point the bottom leg towards the marbles or away from them? Many people would say that the base of the L should face away from the marbles. They probably realize that it is hard to tip the wall over towards the left if the bottom leg points in that direction. In engineering, we call tipping like this overturning. If the bottom leg points the other way around, it is easy to make the wall overturn. So easy, in fact, that I can do it with just a puff of air. It looks like the case is closed. Or is it? Before we declare a final verdict, let's use the model to find out what happens when the bottom leg points to the left, away from the marbles. As we add marbles, we discover that the horizontal forces they produce create yet another mode of failure, namely sliding of the wall. And this occurs when the marbles reach a depth of 3 centimeters. In the model, we can increase the friction between the retaining wall and the base by placing a rubber mat between them. You will have to do some extra reading if you want to find out how they achieve this end in the real world. As you can see, increasing the friction allows our model wall to support a noticeably greater depth of marbles, but it still eventually fails by overturning, in this case, when the depth reaches 8 centimeters. Now let's turn the wall around, so its bottom leg points towards the right, the side where the marbles will be placed. We again use a rubber sheet to prevent sliding, and we add some marbles. As before, the marbles generate a horizontal force that depends on the marble depth. You might be surprised that this wall can hold back 11 centimeters of marbles before it overturns. Can you explain why the wall can resist a greater height of marbles when the bottom leg points towards them? Is there an additional force that comes into play? Recall that granular materials generate both horizontal and vertical pressures. When the bottom leg is oriented away from the marbles, overturning is resisted only by the weight of the wall itself, and so it overturns easily. When the bottom leg points towards the marbles, the vertical pressure from the marbles helps to keep the wall upright. The downward pressure also increases the friction between the bottom of the wall and the ground, thereby reducing the likelihood of sliding. When engineers design L-shaped retaining walls, they imagine them overturning about the point labeled Q. They first calculate how strongly the soil pressure will tend to make the wall rotate about Q. We call this tendency to tip an overturning moment, and we label it MO. Next, they figure out the stabilizing moment, MS, produced by the soil pushing downwards on the horizontal leg of the wall. Lastly, they make sure that the horizontal leg is long enough that the stabilizing moment is at least as large as the overturning moment. Then the retaining wall will be stable. You might be surprised to learn that L-shaped walls are seldom used as dams. The reason is that pressurized water at the bottom of the dam can seep under the base of the dam. And if it does, the resulting upward water pressure on the bottom of the dam can generate an additional moment and make the dam overturn. Lots of other clever approaches can be used to design retaining walls, but we do not have time to discuss them here. To learn more about how soil, water, and other materials interact with structures, we hope you will view our videos on dams, silos and tanks, and tunnels and culverts.
Another type of a load-bearing wall is the load-bearing masonry wall. Load-bearing masonry wall construction technique involves the placing of the masonry units as a layer one at a time. The masonry units are held together by means of mortar, which imparts strength and stability to the whole unit. The key feature of the load-bearing wall is that every wall acts as a load-carrying element. The masonry wall transfers load from the roof to the foundation. Types of load-bearing masonry constructions are stone, brick, block masonry, cavity masonry construction, reinforced or non-reinforced masonry construction, single material or composite masonry construction. This is a sample of a load-bearing masonry construction. As you can see, there are no more columns that supports the structure, the roof of the structure, and the walls are load-bearing walls that are structurally designed to carry the whole the load of the building, and these individual hollow blocks are designed for this specific purpose as a load-bearing masonry wall. So we have the pre-panelized load-bearing metal studs wall. It is used for building exterior wall cladding. The metal can be stainless steel, copper, aluminum. It supports gravity, seismic, and wind loading. In the picture that's shown on the slide, as you can see, these are the pre-panelized load-bearing metal studs. The frames are quite more large compared to the regular panel wall panelings, and these pre-panel metal stud act as a load-bearing partition for the building. This load-bearing partition eliminates the need for structural columns on certain areas. Now we have the stone walls. Stone walls are kind of masonry construction that has been used for thousands of years. The first stone walls were constructed by farmers and primitive people by piling loose filled stones into a dry stone wall. Later, mortar and plaster were used, especially in the construction of city walls, castle, and other fortification before and during the Middle Ages. These stone walls are spread throughout the world in different forms. Stone walls are usually made of local material, vary from limestone to flint to granite and sandstone. However, the quality of building stone varies quite greatly, both in endurance to weathering, resistance to water penetration, and its ability to work into regular shapes before construction. Work stone is usually known as ashlar and is often used for corners in stone buildings. Granite is very resistant to weathering, while some limestones are very weak. This is an example of the use of a stone wall. These stone walls are used for fortification or for the perimeter walls of castles. We can also observe these stone walls in intramuros or in churches that were built during the pre-Spanish time.
There's the big stones in the bottom, and you try to get every stone as far into the middle of the wall as you can. You know, you wouldn't have a long, thin one. And then, as you come up from there, you put your fillings in, you fill all the gaps in. You have to wall them, put them in flat, so they lay flat, so all the weight goes down on them. And as you come in with smaller stones, and you have the batter on your wall. As you come up the wall, it gets narrower. And when we get up a little bit higher, then we'll find stones that will go all the way through, and some of them will even stick out to the inside, and they're called through stones. They hold the wall together. And then eventually, when we get up to the top here, we'll have a coping stone, a big capstone with weight that holds the top down and stops the wall moving. That's what it is. You try and cross every joint, and you try and keep your stones as level and none. You know, it should be solid like that. None of them rattling, and everyone's solid. You have flat stone, you have round cobble, wherever you come across, you have to be able to wall it. You know, use the materials that are available in the area. Big, heavy for splitting stone or for breaking stone. And this end here is tempered, hardened, and this is left soft. And that's for shaping big stones. Or, you know, you'd be able to put stones in half, let the backs off the stone. And then you have your smaller hammers for shaping a little bit and taking three faces on and basically just chipping and squaring stones up. That's the only tools you need, and a piece of string. And that's it.
What's the importance of the piece of string?
Just so to give you a guide to keep it straight, you know?
Now we have the shear wall. Shear wall is a structural member used to resist lateral forces parallel to the plane of the wall. For slender walls where the bending deformation is more, shear wall resists the loads due to cantilever action. In other words, shear wall are vertical elements of the horizontal force resisting system. As you can see in the illustration, the shear walls are located at the middle and the end of the building to address the cantilever action or the overturning of the building. So this shear wall is calculated based on its need, and sometimes we can observe shear walls that are used on the elevator shaft and the stairs. Another type of wall is the non-load bearing walls. Non-load bearing walls are walls inside the property that do not support any structural weight of the building. They do not bear any other weight of the property structure other than its own, also referred as to curtain walls. Non-bearing walls are used primarily as room dividers and generally serve no other purpose. These are some types of non-load bearing walls. We have the hollow concrete blocks, the facade bricks, and the hollow bricks. The hollow concrete blocks have one or more two hollow cores. This core reduces the total cross-sectional area of the block by at least 25%. In general, a hollow core concrete block is more than 50% solid. Standard hollow concrete blocks come in full and half sizes. Full-size blocks are rectangular and have two cores. Half-size blocks are cubical and have one core. These are the samples of hollow concrete blocks. As you can see, we have the different types of models of hollow concrete blocks depending on the suppliers. The stretcher three core is the most common type of hollow blocks as being seen in the Philippines. The double core, the other types of hollow blocks are not can easily be procured. But if you need these types of hollow blocks, you can look for suppliers that are reliable and they make this type of sections or molds. The other type of non-load bearing wall is the facade brick. The brick veneer is usually a single layer of full-size brick installed adjacent to a home's exterior wall. So the inner wall bears the weight of the structure and not the brick. In this instance, the brick serves as a decorative element. This is an example of a brick veneer wall. As you can see, the foundation wall the foundation wall supports the main structural frame of the building, and there's a brick wall that is attached to the main the main frame of the building. So the brick wall doesn't carry the building; it carries its own weight, and it's only a architectural or attractive design that will be installed for purposes of aesthetics. So another type of non-load bearing wall is the hollow brick. The hollow clay masonry unit whose net cross-sectional area is every plane parallel to the bearing surface is not less than 60% of its gross sectional area measured in the same plane. A brick having holes through it which a total at least 25% of its volume, the holes being not less than 3/4 inch thick in diameter. So this is a sample of a hollow brick wall. So this is a non-load bearing wall, and this often used as a part of a decorative architectural feature, or sometimes this is used as a partition. So another one is the cavity wall. The cavity wall insulation is used to reduce heat loss through a cavity wall by filling the air space with material that inhibits heat transfer. This immobilizes the air within the cavity, preventing convection, and can substantially reduce the space heating cost. So this is another type of wall This can be a load bearing, this can be non-load bearing. So this cavity wall, there is a space in between two walls, and that space is being used to put insulation, and sometimes it is used to put the utility lines like the water, plumbing, and other communication lines in between the cavity wall. So another one is the partitions. No, the partition walls are non-load bearing walls that separate spaces in the building, as well as spatial divisions. They can provide privacy, acoustic, and fire separation, and flexibility of layout. Partition walls can be solid, typically constructed from brick or blockwork, and can be frame construction. Frame partition walls are sometimes referred as to the stud walls and can be constructed from a timber, steel, or aluminum frame clad with boards such as plasterboard, timber, metal, fiberboard. Partition walls may be glazed. We have different types of partition walls. These 13 types of partition walls, which is the brick partition, reinforced brick partition wall, hollow and clay brick partition wall, concrete partition wall, glass partition wall, straw board partition wall, plaster slab partition wall, metal lat partition wall, AC sheet or GI sheet partition wall, wooden partition wall, lumber partition wall, asbestos cement partition wall, and double glazed partition wall. Another type of a wall is a panel wall. There are three categories of wall panels. We have the high mass, low mass, and the mixed mass wall panel. Along with the equality of materials, you should be aware of its thermal performance, durability, maintenance needs, and many more. So in selecting the wall panel wall, we need to identify what is the use of this panel wall, considering the performance of the wall. So we have this SIP panel. SIP consists of insulating material of rigid insulation material sandwiched between two structural skin of sheet, metal, plywood, fiber cement, or engineered timber. This panel wall system usually achieve high level of structural efficiency with high insulation level. Another one is the AAC block. These blocks are prone to impact damage, provide fair insulation and durability. The AAC block have low processing impacts as well as moderate transport requirements. Another type of panel wall is the concrete block. The concrete block walls, when filled with concrete, can exceed the embodied energy of brick. They have good thermal mass but low insulation values. Another type of panel wall is the timber, the most common form of low mass wall construction material, as it is lightweighted, reduced heat loss, and can have minimal embodied energies. From all the above wall panel, the SIP panel or structural insulated panel are the most preferred ones. SIP panels are most effective as they position the mass where it is most useful in ensuring integrity and insulation.
Are you ready to build your dream home? Consider the building envelope first. A tight, extremely well-insulated home will provide a more comfortable living space and save thousands in energy expense. Energy Panel Structures, EPS, specializes in using structural insulated panels, or SIPs, for new home construction. Our structural insulated panels use high-performance rigid foam, chemically bonded to oriented strand board or plywood. This continuous bond provides incredible strength and resistance to impact. Optional electrical wire chases can be placed horizontally or vertically in the panel. Wall panels are installed over and fastened to a base plate. Assembly starts by fastening corner panels together using both interior and exterior surface studs and SIP screws. Sealant prevents air and moisture from penetrating the panel. This foam is used to seal along the bottom of the panel as well as in between each panel joint. EPS packages include pre-assembled factory insulated headers, along with window and door cutouts designed to match each custom designed home. Adjoining panels are connected using a block spline system and approved fasteners. All EPS panels are numbered and marked. This means walls go together quickly as they tilt up and are put in place. Another major advantage of our panels over stick-built systems is that EPS panels can be manufactured up to 24 feet tall or 24 feet wide. Fabricated panels are cut to fit each project and ready to assemble. The panel edges are factory routed to accept plates and splines. EPS manufactured pre-engineered floor truss systems complete the package. SIP's roof panels can be used to create large open spans or vaulted ceilings. EPS manufactures roof trusses, which may also be used, depending on the specific home design. The EPS building system creates a superior building envelope with high thermal resistance and minimal air infiltration. Home building is complex. Worry less about the details of energy-efficient building practices. Trust EPS and our network of authorized dealers to build your once-in-a-lifetime, and enjoy the peace of mind that comes with a properly engineered and constructed home. Let us deliver more comfort, quality, and durability. Contact EPS at 800-967-2130 or visit epsbuildings.com for more information.
Another type of partitions or wall is the veneered wall. Any wall having a facing which is attached but not bonded to the wall. With the veneered wall, we are holding up the material. It can be made of brick or stone. The most famous veneered wall is made of brick. The wall is only 1 wide thick. It became the norm when building codes began to require insulation in the interior walls. It is light-weighted. The construction takes less time to complete in veneered walls. So this is an example of a veneered wall. As you can see in the section, there is what you call a structural wall that is being attached, that the veneered wall is being attached to the structural wall by use of a mortar, or sometimes use adhesive.
Add a decorative accent to almost any wall in your home with the natural look of stone veneer. New engineered stone veneers are lighter and more budget-friendly than traditional stone, and they're easy to install, only requiring a few tools and special adhesive. Follow the manufacturer's directions for your type of stone. Start with prep. Calculate how much stone you'll need by measuring your work area and subtracting areas that won't be covered. Then add 10% for extra. Let the stones and adhesive acclimate in the room for 24 hours. This is a good time to remove any bumps or nubs on the stones and to plan your layout. Mix stones from different boxes and alternate sizes to break up vertical seams. As for your work area, it must be flat, clean, and smooth. Lightly sand surfaces painted with oil-based paints. Also check that the floor, countertop, or molding is level. If not, find the lowest spot, hold a stone in place, mark the top, and extend this line along the work area. This would be your guide for cutting the first row to fit, keeping things level. Here's a tip for wood floors. Use shims under the first row for future floor repairs or renovations. Now, mark the vertical layout on a long, straight board. This is called a jury stick. Hold it against the wall and adjust the starting line as needed. Start the install at the bottom corner. With a putty knife, apply a thick layer of the adhesive to the back of the stone, sort of like icing a cupcake, and press it onto the wall. Do the same for the next piece, keeping the joints tight, and finish row 1. Make sure everything's level. Then start the second row. Remember to stagger the joints and keep them tight. At the row ends, use a natural stone edge for a finished look. To cut a stone, mark it and cut face side up with a masonry blade or hacksaw. Hide the cut edge toward the middle. For corners, reverse the special corner pieces with each row. Continue installing, periodically checking for level, and wiping off any adhesive that gets on the face of the stone before it dries. and that's all there is to it. Cleanup is as easy as using warm water for interior adhesive. An ordinary wall gets an extraordinary makeover with the natural beauty of stone veneer. Want more great ideas and how-tos? Go to Lowe's.com/how-to or just click to subscribe. Next, learn how to hang drywall.